Okay, so network design, the new unit, and understanding the network fundamentals or understand the networking fundamentals. So the term is a network, and in this unit, you will be able to understand the design fundamentals and should be able to design a network for a client. Yeah. So are you getting my voice? Yeah.
Yes. Sorry, I was on mute.
Okay. So basically, would it be okay if you know the concepts or don't know the concepts, or for example, if you have studied and some of them might be, repeating for you, but I should, straight away go through each and everything, yeah, and you can raise any question in whenever you want in the middle.
Yeah, that's fine, Ajaz.
So because we have to, the slides are 55 for today, tonight. Yeah, it's a night now. Yeah, and let's try to cover each and everything. Yeah.
Yep, no problem. Thank you.
So network define and networking define. Yeah. So a network is a set of connected computers. When you say that computers are connected, they have formed a network called the nodes. Yeah. And networking is a process itself for creating and using and utilizing the computers. Yeah, a total process. So sometimes we interchangeably use the word I'm working on networks or I'm working on the networking. Yeah, but the definitions and the terminologies, they are a little bit different. Yeah.
Yep.
Okay. And then if you have a network, yeah, I'm following basically the indicative content, yeah, and the according to the this file given by the awarding body, yeah. So in sequence, if there is a network, then you have got a network application cell as well, yeah. So when it comes to you, what are the network applications? So over the network, when the computers are networked, yeah, and you have got a resources shared, then you can have the different types of the applications, yeah. For example, the web browsers. The web browsers are especially used for the content of the World Wide Web in the form of pages, which is the HTML. So Mozilla Firefox, Google Chrome, Microsoft Edge browser, previously known as the Internet Explorer, Opera, these are the one kind of the network application. Email applications, yeah, normally we use through the the email providers like a Hotmail or the Gmail, but you can also configure the pure applications on your computer like a Microsoft Office Outlook, Mozilla, the Evolution, and others. You definitely know the email clients and applications, the desktop based applications, isn't it?
Yes.
Then the instant messaging is also the one kind of network application, like use Microsoft Skype and WhatsApp application messenger. No matter if you use on the on mobile or the computer, but the instant messaging is also one kind of the network application, isn't it?
Yes.
Yeah. Then collaboration applications. These applications, are mainly used inside a company for a group of employees to work together for a common task. So SharePoint, Microsoft SharePoint, Zoho Connect, Oracle Beehive, Google G Suite, or maybe let's say uh, Excel thing or document sharing on the Google Docs, and many more things. When you use such kind of applications, yeah, for the sharing purpose, then they would be called as a collaboration applications. Yeah.
Yep.
And other network applications, when you say the cloud computing, yeah, and the cluster computing, or utility computing, or the pay-as-you-go computing, isn't it?
Yes.
So these are basically the applications of network. Make sense?
Yes, yeah, they do.
The good classification and the revision of the types of the applications, isn't it?
Yes.
And obviously we can further do the research into individual type of the network applications. Yeah.
Yeah.
So always, every subject has an in-depth terminology. Like when you talk about the databases, you go into the further details, and you split the tasks and the individual topics, and you get again uh, an ocean of the knowledge, isn't it?
That's right, yes.
Yeah. So networks, the networking, and then the applications, and then you need a network operating system as well. Yeah. Network operating system is an operating system designed for the sole purpose of supporting workstations, database sharing, application sharing, and file and printer access sharing among multiple computers in the network. So, for example, the network applications which we were discussing in the previous slides, you require a pure, a solid, let's say, a kind of operating system as well. For example, if it is a Microsoft Outlook, application for emails, then probably at the higher level, and at the for a customized and extensively manageable computer, yeah, for email, or the uh, file sharing, or even, for example, don't look at that, you are using the Outlook, for any Hotmail or any website domain email. But if you want your email domain, yeah, of your websites, yeah, and being stored on your computer, on your own server, make sense? Yeah.
Yes, yeah.
You don't want to hire any server, at all. But if you want to configure an email server on your own, then you would need to install the application of the email server, as well as its corresponding operating system should also be a kind of network operating system. Make sense?
Yes, yes.
Yeah. So for the yeah, what
Sorry,
you need? Yeah,
sorry.
yeah. Sorry. Yeah, go ahead.
So sorry, just to confirm. So this is so a network operating system is an operating system that has the networking capability, such as Windows 10, Linux, things like that.
Windows 10 has a partial, networking capability. Yeah, I would say a partial networking capability. But when it comes to the Microsoft Windows Server, yeah, 2007, 2013, yeah, it has a much more, it's purely called as a server operating system or network operating system.
Yeah, I understand. So that's dealing more lower down the application level, lower than the
Yeah,
application level.
more than the application level. And luckily, I was, not adding these features, yeah, but I did it, and they are good. The silent features of the network operating system are basic operating system features, support like a protocol support, processor support, hardware detection, multi-processing support for applications, as well as security features like authentications, restrictions, authorization, access control, and features for file, web, printing, replication, blah, blah, blah. And as well as the user administration, system maintenance activities, tasks associated with the file management, security monitoring on all resources in the network, setting priority to print jobs in the network. So even these more additional silent features, are the characteristics of the network operating system. Yeah.
Yeah.
Like security monitoring and logs, you must have used the Windows server, and whenever you wanted to restart, then every time it would be asking you that why did you restart? What was the reason? Did you ever get the chance to use the Windows server?
I haven't, but I've worked with Linux.
Yeah,
servers,
Linux. Yeah. So I think in the Linux, there are lots of the options and the varieties. One are the normal one, and others are, I'm not sure, but I think there's a variance that some work as a server and some work as a normal one, like a Windows 10 and the Windows server, isn't it?
Yes, that's right.
Yeah. So for network applications, you need an appropriate operating system. Yeah, which should be the network operating system, more network oriented operating system. Yeah. Then furthermore, we talk about the types of the networks. Mostly we look at the local area network when we create a network within our own home or office. Yeah.
Mm-hmm.
I think the simplest things, would be okay if I would be, skipping to the next slide. Yeah.
Yeah, no problem. Happy with that.
Yeah. Then wide area network is basically we can say it's the internet one. Yeah. And the wide means worldwide. Yeah. You can say, because there is the W stands for the wide, and wide is up to the world. Yeah. Then so we have a LAN, yeah, and we have a WAN, and the internet we get is a combination of the LAN and the WAN. Do you agree?
Mm-hmm. Yes.
Yeah. What you do, you connect your individual, local area networks with, WAN, wide area network, and obviously using some gateways and the internet via internet service providers. Yeah.
Mm-hmm.
So there can be a little bit more detail, that how we get the internet, and obviously the internet service providers this internet service. They have got the gateways, yeah, and we reach to them via routers or modems, yeah, and using the telephone lines. So that's the idea behind how we are connected with the internet. Yeah. So apart from the LAN and WAN, there are other networks like Metropolitan area network, campus area network, personal area network, storage area network, system area network, passive optical local area networks. You must have heard about few or all of them, isn't it?
Yes.
Yeah. Do you want me to move to the next slide, or
Happy.
Okay. Now, furthermore, so networking, operating systems, and the type of the networks. Now, we look at the type of the system now. Yeah. When it comes to the peer-to-peer, it means in which one or two computers share files and access to the devices such as printers without requiring a separate server or computer or server software. Make sense?
Yeah.
So, for example, if you have a home computer and you are directly a home network and you are directly accessing the printer, yeah, and via your router or the hub, whatever you have, and when you give a print job to the printer, basically you are doing a peer-to-peer job. isn't it?
Yes, yes.
Yeah. And sometimes, one of the printer which is connected with a server or with a computer, yeah, and when you share the resource of that particular computer, for example, the printer on that particular computer, then how you get connected to the printer? You request to that particular computer who shared it, and then the printing job goes to that computer, and on the request the printing is done. Is that clear?
Yeah, yes.
Yeah. Previously, when the printers were not capable enough to be available on the network few years ago. You remember that area, that time?
Vaguely.
Yeah, yeah. So in those days, when the the printers didn't have the capability to get connected on the network, then the organizations used to have a dedicated the print server, yeah, and the server used to connect it with the printer, and they only used to keep it up, yeah, just for sharing one printer.
Yep.
Can you imagine it?
Yeah, it wouldn't have been very effective.
Yeah. So when you are directly communicating with computer or the printer, then it's called the peer-to-peer. Yeah.
Yep.
Then client server network, like if you dedicated a computer and it is serving the other clients for any purpose, and it would be considered as a client server. Yeah.
Yep.
Then cloud system, again a system which lets you get the resources, yeah, or the computing power or the computing resources shared, is also a type of the system, isn't it?
Yes.
Okay. And then the cluster network or the cluster system, yeah, is a system which is a combination of two or more computers working parallelly in order to increase the computing power. Yeah.
Yep.
Parallelly, in a sense, they are basically tightly coupled. Yeah. So the networks, the clouds, they are loosely coupled because they are not that much, they are over the network. But cluster one, they work together, and these networks, they work in parallel processing. The parallel processing is basically you interface the computer, yeah, very closely. Probably you use some blade. Have you heard about the blades of the computers?
Yeah, like server blades.
Yeah, server blades. Yeah. So when the server blades, work and together, then it becomes a cluster.
Okay.
Yeah. And obviously they how they are connected, and again they are connected with the LAN cards, yeah, and with the gigabits of LAN cards, isn't it?
Yep.
Yeah. Then network virtualization, yeah. What happens, sometimes you split the network virtually, and sometimes you join the two different networks to show a one virtual network. Make sense?
Yes, yeah.
Yeah. Like for example, within an organization, yeah, and even for example, if the organization is divided into two buildings nearby, and if they have a difficulty, then they can virtually make one network. And for example, if the one organization has got in a small building, they have got lots of computers, yeah, and they want the virtual division, then they can virtually, even the computers are connected into the same router, yeah, but virtually they can segregate the different networks into different networks. Make sense?
Mm-hmm.
Yeah.
Yep.
Terminal server. Yeah. So terminal server is a server over the network without using a modem or a network interface card, and it would be, help you to give you multiple client connections. Yeah.
Mhm.
Is it it's also kind of, the server type or the system type.
Yeah. Is that
Like a
yeah,
terminal
yeah.
server is a server or a network device that enables connections to multiple client systems to connect to a LAN without using a modem or network interface. So, for example, if you have, the uh, computer, yeah, and you are able to connect it, yeah, without modem, yeah, or a network interface, yeah, and that's called the terminal server, and basically that terminal server is an old concept. Microsoft introduced this concept by releasing a terminal server as a part of the Windows Server operating system. And what used to be into the terminal server, the users were given the screens and the keyboards, yeah,
Mhm.
and they didn't have more, computing, CPU. They used to rely on, the main server. Well, anyways, that's an old, basically little bit old concept of the terminal server. That's not the new one. Yeah,
Mhm.
yeah. So we move to the next one, and you can further, look at into the terminal server. The basically the old concept.
Yep. Okay.
Yeah, a web server. Yeah, especially dedicated to host the websites. Yeah, then
Yep.
file server, especially used for, the storing the files, like when you create an active directory and, you try to save the files and give the storage to your, network users. Did you ever get the chance to use, the storage, storage capability of your login account and saving on the server
Yes, I have.
in
Yeah.
active directory? Yeah.
Yes. Yes.
Yeah. Right. So, just try to give an idea of these, type of the systems. Yeah.
Yep. Yep.
Hopefully those should be cleared. Yeah.
Yeah. Yeah. They are. Thank you.
Basically, that the indicative content are limited into these, the unit description, but I tried to add, a kind of a detailed, material into these slides this time. You must be, looking at this, that I'm going through very much detail and, the lots of possibilities, isn't it?
Yes, I have.
Yeah.
Yeah. Yeah.
It's always good. Previously, we used to be very much, to the point according to the indicative content. Yeah. But it was not, helpful for us to discuss in more detail. Yeah. And the students, like they also used to be a kind of, uh, you know, quick glance, but they didn't have a chance to read into the detail, isn't it?
Yeah. Yeah.
Yeah. So up to the server types are done. Now network protocols. Yeah.
Yeah.
So is it okay? We should continue until 9 o'clock.
Yeah. I'm good at jazz. So yeah.
Yeah. Yeah.
Perfect.
Yeah. So network protocols, they are the rules, standards, policies comprised of, rules, procedures, formats that define communication between two. So if you want to do the communication between the two computers, you are supposed to use some network protocols on both sides of the computers. You must be aware of the protocols. Yeah.
Yeah. Is that IP version 4 and version 6?
Yeah. Yeah.
Yeah.
So there are certain types of the protocols. Yeah. Which is the one of them is a routed protocols. Basically, the routed protocols are when you try to send a data from one network to another network. That's these two. There's a one sentence definition for the routed protocol. Yeah. So if you could imagine to send something from one network to another network, it means definitely you would be using any application that we used earlier, the network applications, isn't it?
Yes, that's right.
Like something is leaving your lane and reaching to the other network. Yeah. So these are basically the routed protocols, and the IP is one of the example mainly used for the routed protocols. Yeah.
Yep.
Then furthermore, some theoretical and the backgrounds on the routing. One second, sorry. The routed protocols, yeah, used for the sending data from one network to another network. The next is the routing protocol. Yeah.
Yep.
Routing protocol is basically learns the routes for a routed protocol. Make sense? So every routed protocol may not be the routing protocol, but routing protocol must also be a routed protocol. Make sense?
Is that the one where it learns based on the quickest destination or the best destination to get the packets?
It's the destination, alternative routes, and whichever the route is nearest, and so that's right. The paths. Yeah. So you got the difference now. The routing protocol helps you to find the paths as well. Yeah.
Yep.
Now, furthermore, the routed protocols, IP, IPX, and AppleTalk, and the routing protocols, furthermore, yeah, because some of the applications, they require, for example, if you are broadcasting something, yeah, and over the internet, the broadcasting, could be done via different, routes, isn't it?
Yep.
Yeah. So, for example, if we want to access, the Australian server, yeah, then Australian server may be, nearest to us via, the traveling via Europe, and then, the Asia and the Australia, and probably we could go through the USA and then, the other end of the Australia, isn't it?
Yes, very much so, yeah.
Yeah. So that's the idea behind it. And then furthermore, there is a non-routable protocols as well. Yeah. So the non-routable protocols cannot survive behind. The non-routable protocols cannot survive being routed. Yeah. Non-routable protocols presume that all computers they will ever communicate with are on the same network to get them working in a routed environment. So if you have only one network, then you are not using a routable as well as routed protocol. Make sense?
Yes.
Yeah. So NetBUI, DLC, LAY, DRP, MOP, these were the the non-routable protocols. Yeah.
And these aren't really used today, are they?
These are, sorry.
I says these aren't really used today. They're not common, are they?
Yeah, they are not common, and even basically that nowadays the devices we are using, yeah, and we shouldn't be bothered that whether it's a non-routable or routable, but even if it is a routable protocol, for example, then those protocols would be that much efficient, yeah, for working as a non-routable operations, isn't it? Like, the non-routable cannot be routable, yeah, but the routable, if it is working for a non-routable purposes, it won't affect, at all, isn't it?
Yes.
Okay. Furthermore, the internet protocol, the IP, yeah, is one of the, main protocol to be used on the internet. Do you agree?
Yes. Oh, yeah, definitely. Yeah.
Yeah. Then furthermore, difference between the IPv4 and the IPv6. Now, can you tell me what is the difference between the IPv4 and the IPv6?
Yes, it's because the internet grew so much that they ran out of the number of digits to be able to create enough addresses. So IP version 6 can then have more hexadecimal digits to increase that capacity.
Yeah, that's good. So IPv4 is basically the 32-bit address, and IPv6 is 128-bit address space. Yeah, which allows the 340 undecillion, which is basically that a number with 36 zeros. Yeah.
Yep.
So like when we say like hundreds, thousands, and millions, yeah, and billions. So this is called the undecillion, up to 36 zeros. Yeah. So
Yes.
more theoretical detail available on this slide. Yeah. So is it okay if I move to the?
Yeah, that's fine.
So here is a comparison chart. Yeah, that when it was introduced, IPv4 was introduced in 1981, IPv6 in 1999, size, and the more interesting thing is that the IPv4 has a IP address into the four digit four digital numbers, yeah, or decimal numbers, I would say, not digital, four decimal numbers, and however the IPv6 has got four hexadecimal numbers.
Yep.
Yeah, a decimal number, yeah, of having the can I ask, very well, you should be able to know, the bit, byte, and the uh, megabyte, yeah, kilobyte, yeah.
Yeah.
So like, the in IPv4, can you please tell me what maximum number could be used into this first number?
Or is it 4 digits? Is it 4 binary digits?
Not binary. I mean, here is written, 192.
Or
Into
the maximum number?
yeah.
I think it's 256.
Yes, but no.
Okay.
Yeah, you are closest. It would be the 255 basically, and it would be the 0, which would be, the 256th.
Yeah. I
Because
remember.
if you would count from the 0, then the maximum would be 255. Yeah.
Yep.
Because when you knew about it, then the how many numbers a byte can hold, you would be, assuming it's a 256, and you answer 256. But there could be, an examination question, then select how many numbers it can have. Probably you knew that, it would be 256, and what would be that number, and by mistake you would be selecting 256, the one that you said now. Yeah. So that's basically but you are closest, you have studied. So over here, the maximum number using using a byte is 255, is the maximum number. However, this hexadecimal number using 4 digits would be a very big number. Yeah.
Yeah, is it six times the amount?
Well, we leave it at the moment. How much it would be? Let's move to the next one. Yeah.
Okay, cool.
Now, a very good concept that how basically the IPv6 is used for interfacing. You remember the previously lots of devices, those were used basically with the concept of IPv4, isn't it?
That's right, yeah.
Yeah. So IPv6 EUI, extended unique identifier, what they do now, they basically are putting in between four hexadecimal numbers, FF and FE. Yeah. So it would help them to split the address for converting the old address into the new address. Yeah.
Yeah.
So the previous MAC addresses, you understand what the MAC address is?
Yes, so the MAC address is the unique identifier for the network card or device it's going to.
Yeah, network interface card device or any interfacing device, yeah, which is available in the networking, yeah, uh, because the not only the computers but even nowadays a machine, for example, washing machine, which could be operated via network, yeah, will have a MAC address, isn't it?
That's right, yeah.
Yeah. So what they do now they put these FF and FE to four hexadecimal numbers in order to make it a 64-bit address for the device. Yeah.
Yep.
Then furthermore, few more protocols: SP, HTTP, SMTP, POP3, SSL. These are the protocols. Yeah. So you should be okay to study in detail. Yeah.
Oh, yeah, I'm fine. I'm really fine with them, yeah.
Yeah. Then further the network topology, yeah, that how the physically the network looks like, yeah. So the network topologies you must have studied in detail as well, yeah, before.
Yeah, I'm good with them.
Yeah. So bus topology and the star topology, ring topology, and mesh topology. Yeah. Do you
Yeah.
know something about the difference between the physical topology and the logical topology?
So my understanding of the logical one is there is no concept of distance, whereas the physical one there is.
Yeah. So the most suitable word would be the arrangement, not the distance. In the physical topology, the arrangement of the networks and the way they are connected to each other matters. However, what the way the computers are connected, the logical topology can enable you to make the logical arrangement as much as possible according to your requirement. That's the difference basically. Yeah.
Okay, thank you.
And furthermore, the logical topology is further divided into logical bus and the logical ring. Yeah, they could be working like a logical bus. The bus is that computers connected to the in a straight line like a star, and like this one, bus topology. Yeah, and the logical one ring is the further into ring. But the main thing is the two. When we talk about the Ethernet and the first before I discuss little bit more on the logical topology, here is somehow the comparison in between the physical and the logical one. Yeah.
Yep, that's a good one, yeah.
So the physical one refers to how a network looks and functions, and the logical one says the fashion in which the data travels logistically. So the bus, star, ring, and mesh are the physical one, and logical bus and the logical ring, they are the logical one. Yeah. Furthermore, if you remember the token ring and the Ethernet, yeah. So these are basically the logical topologies. They enable you to work as a logical topology, yeah.
Yeah.
Okay. So let me move to the few more other things. Yeah. Now that was about the topology. It's a very old concept. Not old, but we have been studying since ages. Yeah. Now wireless networks. So wireless network is without using the wire, using radio signals, radio frequency. Yeah.
Yes. Yeah. Yeah.
And then the radio frequency in furthermore, for a wireless network, you need a wireless access point. Yeah. Wireless access point would work like a server that would be responding to the wireless clients, yeah, using radio frequencies. Do you agree?
Yes. Yes.
Yeah. So that's about the uh, wireless network, and over the wireless network, two main components are important. Yeah. So two main components, which is the you know web, and other one is a client. And for the client, you need a network adapter, always a wireless network adapter. Yeah.
Yeah.
Furthermore, the types of the wireless networks are wireless local area network. When you use the wireless network like a router, which has web integrated. Yeah. When we say we have a wireless router at home, it means it has a web, yeah, wireless access point integrated and inbuilt, isn't it?
That's right.
Yeah. And when you use a wireless personal area network, then mostly you use the infrared and the Bluetooth technology.
Yes.
Yeah, because when you try to create a personal area network, then most of the time you use infrared and the Bluetooth technology. Yeah.
Yep. Yep.
We use the Bluetooth every day, and some of the devices are still there which have got the infrared connectivity. Yeah.
Yep. Yep.
Did you ever got a chance to use those?
Yeah. Well, a number of years ago, I can remember using infrared, but I think Bluetooth is
Bluetooth has replaced the infrared, and no one is none of the I mean, there are rare applications which come with the infrared, isn't it?
Yes. Yes.
Furthermore, the wireless metropolitan area network, yeah, and that's basically could be used using a fiber cabling. At the metropolitan area, yeah, probably would be fiber cabling, or copper, or but definitely they are the wireless one. Yeah.
Yep. Yep.
Wireless wide area network is basically the wireless wide area network is a type of the network, and which could be done using the satellite systems or antennas, or 2G, 3G, 4G systems.
Yep. Yep.
Yeah. So our cellular phones, yeah, which we use, can be called as they could work as a wireless wide area networks. Yeah. Because they use the antennas, they can use the satellites. Yeah. And so that's the classification of these types of the networks we use. Yeah.
Yep.
Okay. Furthermore, comparison of these wireless area networks, and what is their coverage, their performance, the standards they use, and the applications they use. Yeah.
Yep.
So is it okay if I should move further?
Yeah. Yeah. That's no problem. Yeah.
Furthermore, the wireless networking device, for the wireless networking device, you require a wireless router, and the wireless router will have a wireless access point. Makes sense?
Yep.
And the wireless adapter is a kind of LAN card, local area network card interface. Yeah. And that every device must have every computing device should have this card if wants to connect it on the network. Make sense?
Yep.
Then other wireless network devices are like a wireless repeaters. Yeah, they regenerate the signals, yeah, to extend the range of the router, isn't it?
Yep.
Wireless phones itself, yeah, they are called the wireless network devices, isn't it?
Yes.
Yeah. And any other device which uses a radio signals to communicate can be considered as a wireless device. Yeah.
Yeah.
Maybe, for example, the washing machine is connected, yeah, has got anything technology where you can control it, yeah, and then that's a wireless device, isn't it?
Yes.
The other types of the conventional types of the network devices: hubs, switches, routers, bridges, gateways, modem, repeater, and as well as access points. Yeah. So I think they should be. I didn't go into each and every detail. Otherwise, the number of slides could reach to the 100, isn't it?
Oh, yeah, very much so. Yeah.
So you can always go through into further detail. Yeah.
Yep.
Now the last topic is the network management. Yeah, is a process of administrating and managing computer networks. Services provided by this discipline include fault analysis, performance management, provisioning of the networks, and maintaining the quality of service. Software that enables network administrators to perform their functions is called a network management software. Yeah. Are you aware and clear about what the network management is?
Yeah. So that's to do with the actual physical cable or the packets of data. It's the latency and things like that.
Exactly, yeah. So management includes the faults analysis, performance. You want to know how the network is performing well, as well as you need to protect the network as well. For example, the next topic is traffic management. You want to manage the traffic, yeah, such as bandwidth, how much the bandwidth is passing, yeah, how much you need to monitor it, and you can inspect the packets, yeah, of the data, isn't it? For optimal network operation, isn't it?
Yes. Yeah.
So traffic management is one of the network management topic. Then bandwidth throttling. Yeah.
Mhm.
Have you heard about this?
Yeah. Is that to do with increasing or accelerating the output or the throughput of traffic?
Yeah, throttling. Yeah. So it's like slowing or speeding of an internet service. Yeah.
Yeah.
Then content filtering. Yeah. You want to filter the content, what the content is, isn't it?
Content
Web
filtering.
content filtering is the practice of blocking access to web content that may be deemed offensive, inappropriate, or even dangerous. Families will be well aware of the need to apply the internet content filters. Yeah, that's a management, isn't it? Yeah.
Yes, very much so. Yeah.
And packet sharper is a device that sits in between the campus network and the outside network. So there is a way that despite of controlling a computer, you are having a device which is working on the network traffic. Yeah.
Yep.
And then the HIDS or NIDS, these are also the systems which are used for the network intrusion detection systems, methods of security management for computers and networks. Yeah. So HIDS anti-threat applications such as firewalls, antivirus softwares, spyware detections, These are the HIDS softwares. In NIDS software, anti-threat software installed on any specific point such as servers. Yeah.
Mm-hmm.
And that's it.
Okay.
Two ways, like, either you should have a server over the network, yeah, which should be monitoring, any incoming, traffic, maybe, and you are otherwise alternatively you are only protecting your particular computer. That's the idea behind. Yeah.
Yes.
Yeah. So it was all about the first LO of the networking. Yeah. So we discussed from the definition of the network to the network types, then the network applications, and furthermore the type of the networks, and more specifically into the wireless networks. Yeah. And then we move to the management of the network. Yeah, using these techniques, and and we also discussed the protocols. Yeah. And so that's enough, and that's all for the today. Yeah. And we will cover the next hello next week. Yeah.
Excellent.
Yeah. So wish you all the best for your remaining work on the assignments, and feel free to contact me anytime whenever you want. Yeah.
Excellent. Thank you, Ajaz.
No problem. Bye. Bye for
Thanks.
now.
Bye.